Perfect. Well, welcome everybody. I'm glad you can join us for this presentation. So as Walter mentioned, today we're going to talk about market research using JMP. And before we get started, what I want to do is tell you a little bit about JMP if you've never heard anything about it before. We're hoping most of you have seen some of our other introductory videos and seen some of our other webcasts. But if you've never seen JMP, JMP is statistical software that runs on the desktop. JMP distinguishes itself by being very visual, very interactive, and very intuitive. Now, JMP is kind of special in that it's intuitive, interactive, and fun to use, but it's still extraordinarily powerful. So I always like to say that JMP is sort of like having a hammer when everybody else is pounding nails with a shoe. So you can get a lot more done with JMP and very quickly and efficiently. So JMP is really a family of products. And if you're at a university, you may actually already have a site license. And so this is what we call the academic suite. And so the academic suite includes JMP and JMP Pro, and it's for the Mac and Windows. So the nice thing about JMP is it runs on either platform. Also, if you're at a university, you'll have access to an e-learning course. Now, JMP also comes in a couple other varieties. If you're doing clinical research, there's a specialty product called JMP Clinical, and there's a specialty product called JMP Genomics. Now, if you don't have JMP, and I'm actually already on the website here, you can get a free trial of JMP just by going to jmp.com and clicking JMP 30-day trial. Now, you can also get JMP a couple other ways. So you can get the campus licenses, as I just mentioned. There's annual single-user academic licenses. So if you're in a class and you want to use JMP, you can go to onthehub.com/JMP and get JMP for a very small fraction of its normal price. So for an annual license for a student, it's only $50 a year. So that's like giving up a cup of coffee or so a month, and you can have incredible statistical software. Now, for more information about campus licenses, or if you're interested in anything else, we have our sales contact, Pawnee Allen. And so if you have any questions, you can certainly email her. All right, so with that brief overview, I want to start and actually give you kind of an overview of what JMP looks like. So let me close my browser window here. And for this presentation, I'm actually using what's called a JMP journal. So let me scroll down here so you can see. Now, the journal in JMP is a way of storing data sets or information. You can use them for presentations, or you can use them as a log of your analyses. And so when I get down to saving and sharing your work, I'll tell you a little bit about making journals. They're a great tool if you're teaching with JMP, but they're also a great tool just for the researcher to keep track of what you've been doing and what you've already done. All right, so let's take a look at JMP. I'm going to click on this link here, and this is going to bring up a sample data set. Now, if you're going to follow along, or if you want to try this later on, sample data in JMP, and it ships with over 400 data sets, is available under the Help menu. So let me go there and go to Sample Data. And so this will bring up the Sample Data Index, where in JMP you can look by type of analysis or by type of field, and each one of these gray triangles holds a lot of information or a lot of data sets that allow you to play around with different analyses, which is especially good when you're learning. Nothing makes learning software easier than actually working through real examples. So the data set I just opened, which is called Restaurant Tips, can be found directly if you click the Open Sample Data Directory link, and you can just scroll down to Restaurant Tips. So since I already have this open, I'm just going to cancel out of this and go back to the data table. Now, if you've never seen JMP before, it's going to look probably pretty familiar in that it has a spreadsheet layout. So we have different rows here representing different units of observation, and we have different columns representing the attributes about those units of observation. In this case, this is a restaurant tips data set showing for each table the bill amount, the tip amount, whether a credit card was used, the number of guests at the table, the day of week the transaction took place, what server in the restaurant was actually there, and the tip percentage. And so these are data that might be useful for understanding how tip percentage is related to lots of things about your restaurant, especially something like server or day of week. And so that general organization of JMP looks familiar in that we have this spreadsheet layout, but there's a lot of special things about the JMP data table I want to point you to. Now, the first is column properties, right? Each one of these columns contains a particular type of data, right? Credit card is a no or yes decision, and tip amount is a dollar amount. And notice it even has the dollar sign. Now, to make sure JMP uses these columns correctly, we like to make sure that our column properties are set up correctly. To obtain your column properties, you right-click on a column and select Column Info. And so this will bring up the basic view of your column properties. So let's look at this. Tip amount is the column name. The data type is listed as numeric. Now let me click on this because there's other options here. We could have the data type listed as character, which actually we'll see is what credit card is listed as. Now character columns are special in that they're meant for storing specifically text. Numeric columns take on values that are numeric. Now modeling type is another option that's really important to pay attention to. Modeling type is what the scale is of this variable. Now tip amount here is listed as continuous. Let me click on modeling type so you can see the other options. Another modeling type would be ordinal, and another would be nominal. Now these relate to the scale of measurement. Continuous columns mean that whatever measurements we have, and they have to be numeric, are representative of an underlying scale or dimension. So think about dollars, right? Dollars have a real underlying scale. $0 is different from $1, the same amount that $10 is different from $11, right? That's a true underlying ratio scale. And so we want JMP to know that that modeling is continuous, because what JMP is going to do, and I'll show this a lot today, is intelligently use your modeling types to give you the types of analyses that are appropriate. So JMP is going to be very smart about what it shows you, but you have to help JMP by making sure that your modeling types are always set accurately. So let me show you a different column. So credit card is a different type of data, right? It's yeses and nos, and it's also a different modeling type. So even before I go to the column info, I want you to look on the left-hand side here, and you'll notice that the icon next to credit card is actually this little red histogram. Now that's indicating that this column is nominal. I could even click on that little red histogram, and you can see that JMP has predefined it as a nominal column. Now what that means is the observations here are categorical. They represent a grouping that people are falling into, which makes sense. There's no scale distinction between yes and no. They're simply a categorical representation of something we've observed in the world, whether somebody used a credit card or not. Now, if I right-click on this column and go to column info, you'll notice that its data type is listed as character. Now, whenever you have a character column, it'll automatically set as nominal, which should make sense. If you're representing something as characters, then that is probably a nominal classification. Now, the only time you would need to change this is if you have something like small, medium, and large as your data, right? That is technically ordinal. And so ordinal, if you're not familiar with it, is a type of ordered categories. So small, medium, and large are ordered naturally. Large is larger than medium, and medium is larger than small. So these are transitive. We know that large is larger than small because it's larger than medium, but they're not continuous in nature. They don't have a real scale, which is to say that large is not as much bigger than medium as medium is bigger than small. And so we would just leave, in that case, the categorization as ordinal. Now for credit card, it's nominal. It's just a categorization because it represents categories in our data. All right, so that's modeling types. Now JMP has several menus I want to orient you to, and we're going to use a few of them extensively today. But the ones that I won't use as much are the tables menu, which is very useful when you're restructuring your data. So oftentimes we get data that's not in the format we need, and you'll use the tables menu to stack observations, split a table, transpose, combine tables using concatenate or join. And so your tables menu will be very useful, and we actually have another webinar that's just about restructuring. So that's in the Mastering JMP series, and worthwhile to check out. Now the rows menu are all the operations that deal with the rows in your data set. So this can be going to a certain selected row. So selecting rows where they match certain criterion, select where. This could be excluding or hiding rows. So options we'll look at a little bit today. Coloring rows in your data set, sometimes useful when you have a particular observation that you want to keep track of. Or something called data filtering, which I'll show you later today, which is when you want to consider just pieces of your overall data table. Just like filtering in Excel, you're going to be selecting a portion of your data to work with. Now the columns menu works with, just like the rows menu, but now with the columns in your data set. So when you want to hide or unhide columns in your data table, label particular columns, or even create column formulas. So JMP has a very rich scripting language that'll allow you to make really extensive formulas if you wish to create derived measures from observations you already have. JMP also gives you the ability to group columns. Now, this is incredibly useful when you have extensive data sets, thousands of columns even. And what you can do is take a set of them on the left-hand side and just right-click and go to group. And so in your data table itself, in this columns list, you can keep your columns a lot more organized. And so we won't work with any data that's that huge today, but note that that's a very useful thing when you're working with your own real data. So I'm going to go back and ungroup these here. Now, the final point I want to make about the anatomy of JMP is something called the progressive interface. So I'm going to open this up, and I have a separate section for it because it's really important. So the progressive interface of JMP is what I meant when I said that JMP will intelligently help you decide on analyses. And so the way it does this is, again, based on the modeling type of your data. And so what I'm going to do is I'm going to go to a platform we'll talk about later, Analyze Distribution. I'm just going to select a couple of my columns, so bill amount, tip amount, and credit card, and I'm going to click them into Y columns. Now, before I go on, I want you to think about these different columns. We have two that are continuous and one that's nominal. And the distribution platform, as I'll tell you about later, is a platform that allows us to visualize or analyze univariate questions. And by univariate, I mean questions that deal with a single variable at a time. And so by putting these columns into the distribution platform, I'm asking JMP to help me understand each of these variables separately. But notice that if we're trying to understand something like tip amount, which is numeric and continuous, and when we're trying to understand something like credit card use, which is nominal and character, the types of representations of those data are actually different. We're going to want frequencies for a nominal variable, whereas we may want means and standard deviations and a histogram for continuous columns. Now that's exactly what JMP's going to do. When I click OK, JMP will give us contextualized output that depended on the modeling types of those variables. And so notice for our continuous columns, we have a histogram showing dollars for each of them. We have quantiles showing, min, max, median, and we have summary statistics for each of these. For our nominal column, right, so these are just categories, we instead have a frequency distribution showing us really just a bar chart of how many observations were yes, credit card, and how many were no, and a frequency table also showing us the number missing. Right, so the type of output JMP decided to show us depended on the modeling type of the variables, so intelligently gave us the type of output that made sense. Now JMP goes one step further. These little red triangles, which you'll see all over JMP, so they're all next to any output, and they're also next to the platform description. These red triangles are additional options, but they're special. These are additional options that make sense for the type of data you're working with. And so again, think about the additional things we can do with a continuous column and the additional things we could do with a nominal column. They're going to differ. So let me show you these. When I click on the red triangle for credit card, the options we get all relate to things you would do with a categorical variable. So perhaps turning on a mosaic plot, another way of representing the share of yeses and nos. Or maybe testing probabilities. If we have some null hypothesis about how many people should use credit cards, we can actually test the proportions we've observed in our data set to see if they diverge from what we expected. Right? Those are all actions that relate to a categorical column. Now, for a continuous variable like tip amount or bill amount, the options that live under the red triangle all deal with continuous natured variables. So these are things like testing a mean. Suppose we had some pre-existing conception of what the mean should be for tip amount, based on our previous observations or something like that. We may want to test the mean that we've observed, 3.84, against that null hypothesis, right? So that's going to live under that red triangle. And in addition to this, other options like getting a CDF plot or even getting a normal quantile plot to allow us to diagnose the potential non-normality of this variable, right? Those options all live under this red triangle, and they're contextualized, which is to say that they will give you options, JMP will give you options that relate to the variable you're using. Now I want to point one more thing out. So in this platform, we're looking at these histograms and frequency distributions in a vertical fashion. Now a lot of us are used to displays of histograms on their side, horizontal. Now JMP is very customizable. And so these options, when they're related to displays of the output, normally will live under the upmost red triangle. So next to distributions here, we have this red triangle, and we can simply select stack, which tells JMP that we want to rotate these histograms and see them instead on their side. And so notice that JMP allows you to customize your output in many different fashions to really match what you're trying to do. All right, so that was just a quick demonstration here of the progressive interface, and we'll see this a lot more today. JMP is going to help you through your data analysis, but it does so in a way that makes data processing very intuitive, because as we create output, we're given the options that allow us to dig down further, which is really a natural way of understanding your data. We start off at the highest most level, and we maybe ask a question that brings about new questions. And so JMP's going to help you understand your data and really make sense of it in a very intuitive and natural way. So that's the basic anatomy of JMP. I want to move on to some basic summarization and graphing of data in JMP. Now, even though we often think about data analysis as t-tests or ANOVAs, multiple regression, many questions we have or many uses of our data is simply to make sense of what we've observed. And visualization is an incredibly important component of this, which is why, as you'll notice, JMP always tries to provide some visualization to accompany any type of summary statistic. Because visualizing your data is really important. It's truth that our brains are the best pattern detection and pattern recognition systems we have. And so visualizing data or showing your brain those data in a way that it can process efficiently allows you to make insights and discovery much more quickly than simply looking at summary statistics. So I like to spend a bit talking about summarizing and graphing because it's an incredibly useful way to understand your data. Now to do this, I'm actually going to take away my restaurant tips file for a second. And what I want to open up is a slightly more difficult data set to understand from the start. So this is a big data set of US demographics. So we have for every 50 states, or for all 50 states, we have 16 columns showing us a lot of numeric data. Things like population, high school graduates, gross state product, lots of data here. And of course, looking at it in a table doesn't allow us to understand much about what's going on. So summarizing and graphing this is going to provide a lot of utility for understanding what's simply going on. So the first thing I want to show you is under the columns menu. And this is a very useful tool called the columns viewer for both finding columns in very large data sets. So it allows you to browse and search your columns, but it's also really useful if what you need are basic summary statistics of continuous columns. So let me show you what this looks like. If I go back to my US demographics data set, I'm going to navigate to the columns menu and select columns viewer. Now, as I said, the columns viewer allows you to find special columns, ones that match certain properties. So there's a find columns with properties button here. Very useful when you have lots of columns in a data set and you simply want to find all the continuous ones or all the nominal ones. This red triangle also allows you to sort by name your columns, match case, or look for columns that contains a certain string or doesn't contain a certain string. So there's lots of very useful things this is for. But as far as summarizing, we can simply I'll select a number of these continuous columns, and I can click this button here that says Show Summary. And when I click Show Summary, what JMP's going to do is create this little summary statistics page down below, which will show us for each of these columns the number observed, number missing, the min and max of each column. So at a first glance, this is actually very useful for checking the quality of your data. Often when we collect our own data, we get some strange outlying points. Maybe there was a data entry issue, or maybe somebody misunderstood the question. So it's always good to look at the min and max just to make sure there's nothing way out of bounds. And we also, from this output, get a mean and standard deviation. If we like, we can go to the red triangle, again, which will always show more options that make sense from this output, and we can select Data Table View. And so if we need to make this little output into a real data table, possibly because we want to process the data more, or because we want the actual values so we can copy and paste, we can make a data table and actually use it just like a regular JMP data set. And so the columns viewer, if you have a lot of continuous columns, provides a very quick and easy way to get a lot of summary statistics. All right, so that's the columns viewer. Now the next platform I want to talk about is called Tabulate. And Tabulate, I have to admit, is one of the things that won me over on JMP the first time I used JMP, maybe 8 years ago. Tabulate is an incredibly powerful platform that allows you to create essentially tables out of your data, but to do it in an intuitive and natural way. And so let me show you what this looks like. Let me keep US demographics open for a second. I'm going to go to the Analyze menu and select Tabulate. Now I'll just make a note, if you're using JMP 10 or earlier versions of JMP, Tabulate used to live under the Tables menu, but now it's under the Analyze menu. So let me select Tabulate. Now as I listed here, Tabulate is built around drop zones. And what I mean by that is there is a basic table on the right-hand side that you're going to be able to create by simply dragging and dropping columns into different drop zones. Now JMP has certain customs for how the drop zones will work. And as I go through this example, I'll point out the little conventions that'll help you make the tables you're trying to make. So for instance, let's say we're interested in a couple of these continuous columns. So population, 8th grade math, and high school graduates. I'm going to drop these just right in the center because let's say I'm interested in understanding something about those columns. Now when I dropped them in the center, this told JMP that I want to consider these variables as columns I'm trying to understand. And what it's going to do is pick a default summary statistic for these columns. Now it shows sum, so that means it took the sum of all the observations across the 50 states for population, 8th grade math, and high school graduates. Now sum is fine, but typically we're going to be more interested in things like the mean of a column. And so to change this summary statistic, we have a couple different options. The first is to click on the mean here in the list of statistics and drag it right on top of sum. And by dragging it right on top, this is telling JMP I want to replace that summary statistic. Now this is a convention that typically works in Tabulate. If you drop something on top of something else, it typically tells JMP that you want to replace it. On the other hand, I can drag right to the right-hand side and notice the drop zone has changed. If I hold right to the right-hand side of mean, there's a little section there which is telling JMP I want to add this summary statistic. And so if I drop it there, notice I have the mean and the sum for each of these different continuous columns. If you ever make a mistake in Tabulate, you can click undo, which will undo the last action. And in Tabulate, you can make tables really of any complexity. So this is a very simple table, but let's say we wanted to break apart these things by region. So region in this data table is a categorical variable. It breaks apart the country into 4 regions. If I want to break apart these summary statistics by those 4 regions, I can simply take this variable and drag it to this little drop zone, which is the drop zone for rows. If I put it there, notice that JMP will break apart now that simple 3-cell table into a table that's 12 cells, right? For every region, the 3 different summary statistics. Now we can do this and make separate tables, or if we like, and I'm going to switch over to a different data set, we can actually create very complicated and very interpretable and useful tables for real data we have. And so I'm going to switch over to a different data set. This is called hair care product. And before I go any further, I'm going to go back into Tabulate and use this in a second. But I just want to orient you to what this data set is. This is actually a very large data set. We have 126,000 rows, and we only have 8 columns here. And what this data set is about, it's a fictitious data set showing us hair care products for some promotion. So imagine we sent out promotions to half of these people, half of the 126,000 people, and what we've recorded is whether they purchased a hair care product or not. And so principally, we want to know the effectiveness of our promotion, but we may also want to know whether the effectiveness of the promotion, if there is any, varies as a function of these other variables. Things like the gender of the individual, age, hair color, what region of the country they're in, or whether their residence is urban or rural, right? So we're going to be able to, using Tabulate, understand a lot about these data that, of course, we couldn't understand by simply looking at a data table of 126,000 rows. So let's go back to the Analyze menu, and I'm going to go back to Tabulate. Now, just like we did for the last example, we're going to take the thing we really want to understand and put it right in the center for the resulting cells. And I think probably the most important thing to understand here is whether somebody made a purchase or not. So I'm going to grab purchase and drag it right to the drop zone for columns. Now I can't drop it in resulting cells. This isn't a continuous column, but watch what happens when I put it into drop zone for columns. Because this is a grouping variable, it's a categorical variable, we're going to be able to split up the output here into how many yeses and how many nos we had. So at the very start, even before we look into anything else, we have a general idea of how many people are really purchasing or what proportion of people would purchase this product. And, sadly for us, if this was our hair care product, it looks like very few people have actually purchased our product relative to how many people didn't. We can get a better understanding of this. Instead of using raw numbers, we can pick a different summary statistic. How about percent of total? So just like we did before, we can change what we're looking at here by simply dragging this into the center. So percent of total for yeses is only 1.2%, and 98.8% of people decided not to purchase our product. Right? So it doesn't look very good for us. But now we can get to our real question, which is, does our promotion affect this purchase amount? And do other things like gender, hair color, region of the country, do they also have some moderating effect on the purchase, or do they have some basic effect? Do males differ in purchasing than females do? So let's use Tabulate to look at this. I'm going to take promotion and I'm going to put it into a drop zone for rows because I want to see the purchasing amount for those who did get the promotional materials versus those who didn't get the promotional materials. Let's grab promotion. I'm going to drag it right there to the drop zone for rows. And right away, it breaks apart that 2-cell table into a 4-cell table. So now we can see among those who didn't get the promotion, what proportion or percent purchased and what percent didn't. And among those who did, what percent did and did not purchase. So take a second to look at this. Among those who didn't get the promotion, 0.36% decided to purchase. Among those who did get the promotion, 0.84% decided to purchase. Right, so that's actually a little bit more. That might seem good for us. Now, we have other summary statistics here that might actually make this a little more evident to us as we look at these numbers. Right, what we could ask ourselves is, among the people who purchased, so among the yeses, what proportion was no or yes for promotion? Let me show you what that would look like. That we can use the column percent. So I'm going to drag column percent right on top of percent of total. Remember, that's going to replace that summary statistic. So what column percent says is, among the observations in this column, the yeses, what percent of those in the yes column got the promotion and what percent didn't? Now that's one way to look at this. We actually have a kind of a special circumstance here. Half of our data set got the promotion and half didn't. So we can interpret this column percent pretty easily. Right? Among those who purchased, a lot more of them got the promotion than didn't. But there's even another way to look at this. We can ask the question, among those who didn't get the promotion, what proportion were yes and no? And among those who did get the promotion, what proportion purchased or didn't purchase? And so that's using a separate summary statistic. That's using the row percent. And so what I'm going to do is drag that up here, drop it on top of column percent, and now we have a slightly different way of looking at this data. Right? So now we see among those who didn't get the promotion, 0.73% purchased and 99.27% didn't. And among those who did get the promotion, 1.68% purchased and 98.32% didn't. Right? So different ways to see the same data. All right, so I mentioned that Tabulate allows us to not just look at this basic level, but we're going to be able to dig a bit deeper. And so to do that, we can use our other variables here to add a separate table below or to break apart this current table. So let me show you both of those. Let's take something like gender. So gender here is male and female in our data set. we can drop gender in a number of different places. The first place I'm going to drop it is right below my existing table. And notice what JMP does is it makes this little drop zone that's a little rectangle underneath my current table. Now dropping it here is going to tell JMP I want a new table that breaks apart purchasing on the basis of gender. And it's going to honor the same summary statistic I had above, so row percent. And so this addresses another question. Among females, how many purchased or didn't purchase? And among males, how many purchased or didn't purchase? The benefit to using the row percent is we don't have to necessarily have the same number of females and males in our data set. We just want to know among the females, how many purchased and didn't, and among those who were male, how many purchased and didn't. And so we can see already another effect, right? It looks as though males are purchasing at a lower proportion than females, this particular hair care product. Now we can do the same thing we just did for gender with a bunch of other variables. Let's take hair color, US region, and residence. So I'll take these all at once and let's create little tables underneath like we did for gender. So I'm going to drag them all to the lower drop zone. And now we get this combined table showing us the same thing, row percent, for each of these different outputs. So among people of different hair colors, we can get a quick glimpse at what hair color is really the most popular for this product, which regions potentially have the highest purchasing rates, and whether there's differences among residences, rural or urban. Now I mentioned that any of these grouping variables can also be used to break apart the levels of another variable. So let me show you this. I'm going to take gender. I can just click and drag it from the table to move it to somewhere else. And what I'm going to do is hover over a couple regions. So notice if I hover over promotion, it highlights the entire cell. And like I said before, the convention would be then to replace that variable with gender. Now we don't want to do that. We actually want to break apart the promotion on the basis of gender as well. And so to follow the convention, I'll hold to the right-hand side or the left-hand side of the promotion level, which will break apart this into separate levels. So take a second to look at what just happened. Now, this top table is showing us, for those who didn't get the promotion, the row percentages of purchasing for females and males. It's also showing us, for those who did get the promotion, the purchasing percentages for females and males. And so in this way, we can get a quick glimpse at whether gender is relating at all to the efficacy of this particular promotion. Now, there's another way that might be even more useful to see this. I had gender on the right-hand side of promotion, which is called nesting of categories. I can change the nesting order really quickly. I can just click and drag gender to the other side of promotion, and I want you to see what it's going to do. Now, within gender, we break apart the categories of promotion. And so I think this makes it a little easier to see that among females, the difference between getting a promotion or not looks to be fairly sizable. That's a difference of a 0.75 purchase rate percent versus a 2.16% purchase rate. But if you look under males, no and yes don't actually look much different. Seems as though males, which we know to be purchasing less frequently overall, but also seem to be somewhat immune to this promotional material. So from a practical standpoint, in seeing these data, it would probably make sense not to focus your promotional materials at all on males, right? They're not really going to help you out. Now, the Tabulate platform, as I mentioned, has a lot of functionality. It allows you to do a tremendous amount with these different summary statistics, and it also gives you a quick way to visualize these data, right? What we're really looking for is where there's the biggest distinctions in purchasing rate. And to see that, I'm going to go to the red triangle at the very top. So these are options that relate to the entire platform. And I'm going to click on Show Chart. Now, this is a very quick graphical way of seeing these different promotional outcomes. Now, it's going to look a little strange because notice right now it's trying to scale these different plots uniformly. That is, within all the plots, it's trying to use the same scale from 0 to 100%. And because the no's so vastly outscale the yeses, all of our yeses here are basically non-existent. We can't see that 1% or that 2%, except for maybe the tiny bit there. Now we can simply uncheck this uniform plot scale, which allows us in each cell to see the deviant categories. And so what this is doing is inside of each cell, it's scaling from really the lowest to the highest. And so if we look at the cell right here where my mouse is, so this is the yeses broken apart by gender and proportion or promotion, we can see yes here is very high. And that's the same thing we saw in the table, 2.16. And so the nice thing about this is looking across all these categories, we can really very quickly see whom we should probably be focusing our promotional materials on. Well, certainly females, we want to do that. We can break apart hair color just like we did for promotion if we like. So I'll take promotion here again, drop it to the right-hand side of hair color. And just like we saw before, we can actually get the broken apart scales. And so we can see for different hair colors, do our promotions actually work differently? So Tabulate's a very flexible platform. And so I think as you go forward, you're going to find that this is one you'll use quite frequently. And if you like, you can always make these data tables or data outputs into proper data tables. And so that again is offered under the red triangle. And I'll make this point a lot. When you're ever looking for an option, the two things to check are try right-clicking or try going to a red triangle. JMP is very customizable and lets you do a tremendous amount of different things. But these options are generally hidden so as to not overwhelm the different things you can do. Right, so that's the Tabulate platform. Now there's a very special platform in JMP, a brand new one, which is called Categorical. And this is available under the Consumer Research section under Analyze. Now, I'm going to talk about this only briefly, but this is worth looking into if you do a great deal of survey research, because it's excellent for survey data. And to talk about this, I'm going to bring up a somewhat difficult data set. It's called Consumer Preferences. It's also available in the sample data directory. And this particular data set is for 448 individuals measured on a whole host of things. So we have some continuous columns like birth year, response ID is just the individual. We have their age in different groups, years at current employer. So we have a lot of demographic information. Then we have some basic survey results. Things like whether you're working on your career, from agree to disagree, whether you want to get your debt under control. And we even have some pretty strange and difficult to process data. So we actually ask these individuals when they brush their teeth. Do you brush after waking up, after a meal, before sleep, or some other time? Now just think about this. If you're trying to visualize data that's collected in this fashion, right? So these are indicator variables. So for different categories, people can mark any combination of these, right? Visualizing these data is actually pretty challenging. And summarizing all of this data would be quite an undertaking. And so the Categorical platform was built to help you do this. When you have these very large data sets and you want to understand a lot of your data all at once. So let me show you the Categorical platform. Again, it's under Analyze. It's going to be under Consumer Research, and it's under Categorical. And so the way Categorical works is you have separate response roles, basically which variables you're going to be using and how those variables are stored. If you just have a simple variable, such as, let's say, I'm working on my career, right? So that variable has simple observations, just simple responses. That would be a response role that just uses simple. And so I can take a couple of these. Maybe I have vast interests outside my work, my home needs some improvements, whether you want to see the world or not, and whether you're working on your career. I'll just click those as responses, and JMP will designate them in this output as simple responses. Now there's some other sections here I want to point you to, and we're going to use one of them in a little bit. But when you have different response roles, like aligned responses, so these are columns that share a common response level that can be aligned together in an output, repeated measures for the same item, so for the same person over time, or even rater agreements you can actually place into here. Under multiple, we have some very special sections, multiple responses. So these are when you have multiple different values entered over several columns, or something called an indicator group. And so this is like those brushing your teeth, whether an item has multiple responses spread across different columns. And so we can play around with these different response roles, but I want to show you a basic output here using simple first. And so I'm working on my career, want to see the world, whether your home needs improvement, and whether you have vast interests outside of work. And let's imagine we want to understand those responses in our survey on the basis of some different categories. Some things about these people that are, fundamental to them. So how about age group? So whether these individuals are of basically young to old, whether these different responses vary as a function of age. What I'm going to do is click that into this X, or grouping category. And I don't have to change anything else. With this setup like this and with all the defaults, I'll get this really fantastic output, which shows me for each of these different sections, so whether you're working on your career, want to see the world, or these other variables, we get a frequency chart showing us for each of the age groups, what the different responses are. This is something we could have made in Tabulate, but notice that very quickly, we're able to create these outputs for all these variables at once. And this share chart I find really compelling. So let me help you read this if you haven't seen one before. Now we're looking at agrees and disagrees. So agree is any red bar and disagree is any blue. Now the agree and disagree section here is split up to be 50-50. So that isn't the share in the overall data set. That's just a reference point for you to see whether people agree or disagree more than 50%. Now, if we look at the different age groups, we get an idea of how the distribution of agreement varies as a function of age. And if we want to look over the entire group, so this is what the all section is, that shows us among most people are working on their career. But among those who are a little bit older, only about half of them are. And so this kind of squares with our intuition. Younger people probably should be working on their careers more. Now, in any of these outputs, notice that we have categorical variables really crossed with another categorical variable. So a categorical age group versus a categorical working on your career. We can do hypothesis tests on these variables. That would be a chi-square test of independence. And in a very jump fashion, those options are going to live under a red triangle. So if you click categorical, notice there's the response heterogeneity or test response homogeneity option, which is going to give you those standard Pearson chi-square or likelihood ratio tests, testing whether there is actually some relationship between answers on this variable working on your career as a function of age group. Right? Presumably this is a sample of some population, and we may want to know among others, do we think there's actually some dissimilarity between the responses for these different ages? And so as I scroll down, you can see that this platform allows us to summarize a great deal of data very, very quickly and allows us a lot of customizability with the different options. And so again, always look under a red triangle if you're looking for different outputs. Now I want to show you how Categorical, this platform, works with a really tricky type of data. And so these are indicator variables. And again, what this means is a subject can answer yes to any of these questions or no to any of these questions. Now, visualizing data like this is actually very cumbersome typically. And if you want to imagine how you would process this in something like Excel or another program, you would have to show essentially the number of responses in each of these categories separately, or potentially take some sum over them to show the number of times people brush. Those are interesting questions, but they're not really showing you the different shares. And so let's look at how the Categorical platform will work with this. Let me go back to consumer research, select Categorical. Now to deal with a variable like this, brushing at different times, we have to go to the multiple response section and select indicator group. And what indicator group will indicate to jump is that the different responses for these different variables really come from the same question. They're just whether individuals indicated yes to either of them or any of them. And now let's again look at this across different age groups. So I'll take age group here and put this again into my grouping category. When I click OK, what Jump will do is create what's known as a share chart. And so let me help you read this as well. So for the different age groups, we're seeing the proportion showing us, or the share for each of the different categories, and also the number of observations. We'll also see in the option down below, so in our share chart, really the overall share of these different categories. And so at a very quick glance, we can see the dominant categories are clearly brushing after waking up and brushing before sleep. The majority of people are doing both of those, and some proportion are doing brushing after a meal. And if we were to infer, let's say without a hypothesis test, whether there's some disagreement or some difference in these different age groups for sections, maybe we would suggest that 45 to 49-year-olds are brushing more after a meal. But of course, that's something we would follow up with a proper hypothesis test. And so I just point out the categorical platform because JMP, when they added this, really extended the functionality of working with survey data. And I've just shown you a tiny little glimpse of what the categorical platform can do. I'll talk a little bit more about resources later on today, or at the end, but I do want to point out for the categorical platform, there's a really exceptional help book. So under the help menu, there's a section called Books. And if you go to the Consumer Research book, there's an entire section that just talks about that new categorical platform. And so for survey data, especially when you're dealing with quite unruly or difficult to process data, I think you'll find categorical really extends your functionality. All right. Now, finally, before we move on to some basic analysis and some saving your work, I want to show you the graph builder, because the graph builder, much like the Tabulate platform, is a drag and drop platform that allows you to understand relationships among variables, but it allows you to do so in a very intuitive way. And so this option lives under the graph menu, and it's called Graph Builder. Now, you'll notice it's set up in a similar way to Tabulate by having drop zones. Now, the Graph Builder actually has a lot of explicit drop zones, and I could talk about each of these with you. But just to show you quickly what it can do, let's imagine we have some interest between, say, age group again. So I'll drag age group down here to my X. Now, before I do anything else, I want you to see what this is doing. What JMP has done is just clustered the points, jittered them really, within each of the sections. And this is good for us just to see, overall, how many observations do we have in these categories. We have no Y observation specified, and so the dimension of Y here is actually undefined. This is simply jittering the points so you can see how many there are. But let's imagine we're interested in whether age group relates to something else. Maybe does the age group relate to salary, right? Do people who are older potentially make more? Let's drag salary to the Y and see what happens. So right away, what JMP is going to do is instead of jittering those points in Y space randomly, it's now spread them out across the Y dimension on the basis of salary. Now, I actually like this view quite a bit. I didn't at first when I saw dot plots like this, but this actually, I think, conveys a lot about the data. But there's some more typical summarizations that you may be familiar with. So you'll see along this ribbon, different options here are highlighted, allowing us different ways of visualizing these particular data. And let me click on the box plots, because this is a great way to see these data. And so what the box plot will do is show us for each of the different age groups, right? The min, max, the median, the quartiles, and it'll also highlight some outliers. So these are outliers by the criterion of 1.5 times the interquartile range plus the outer fence. And so this is showing us points that really, if you were doing analyses, you might want to look into because they are extreme relative to the central distributions within each of these categories. Now, there's some other ways to look at these data too. This is effectively a categorical variable, age group. I can click this little contour plot, which is going to display something very similar to the box plots, but I think does it in a pretty beautiful way. And so let me put the box plots back on. I'll click and drag box plot over it, which allows us to see both the box plot and the contour. And so you can get an idea of what the fatness here represents. The fatness of the contours is really where the bulk of the data are. And so let me turn off the box plots and show you why I like the contours so much. By having the contours on, it makes it really easy for us to break apart this analysis on the basis of something else. So let's go back to something like gender, a very simple variable to break apart. I can drag this to some different drop zones. So let me try group for X first. And so you can see, we see for the different age groups, gender, male and female. We can do it as a wrap, which is going to look the same as group for X. We only have 2 levels. We can do an overlay. And this is one I really like, so I'm going to leave it on overlay. And look what we can see here. So for males in blue and females in red, we can see for each of the different age groups, right, their bulk of data. And now I think the contours make this very, very nice. I'll put on box plots for a second, because that may give you a more specific interpretation, more precise maybe, visualization of the data. But notice that with Graph Builder, you can really understand a lot of complexity of your data and do so in a simple drag and drop interface. And we can definitely get pretty deep here within our different analyses. I could even break apart this analysis by something else. Let's say whether somebody is single or not. And I'll drop that into the group for X. So notice we can get fairly complex with our visualization. As a general rule, use the simplest visualization you need to get across the point you have. So if you're ever creating graphics, don't add a bunch of variables that aren't necessary to make the point you want. So there's certainly a saturation point with humans, right? Once you get to a certain level of complexity, your point will get clouded by the noise. Now, supposing this is what you want, with the Graph Builder, you can click Done, and now you have a graphic that can be saved, printed, exported, or copied to another piece of software. Now, while we have a little extra time, what I actually would like to do is, instead of looking at some other platforms, I want to jump ahead to saving and sharing your work. Because this is really important. Getting your data analysis done in JMP is one thing, but eventually you're going to have to communicate these findings to other people. And so I want to talk about a couple ways to do this. Now, the first and probably simplest, and I don't even have it on here, but it's simply copying and pasting output. And I want to point out how to do this because it may not be natural if you didn't know it was there. So this little fat plus line is called the selection tool. So you can click it in your menu ribbon here, or you can also go to the Tools menu and select it here, Selection. Now, anything you select in JMP, so I'll just select this whole Graph Builder section. Once it's highlighted, you can simply go to the Edit menu and copy it. And now, this is something you can paste into other software. I'll just open Word up real quickly on my computer, and hopefully it'll open quickly, and make a new document. And let me just show you, I can right-click and paste this output directly into Word. Now, what's great for us is that output's actually pasted at incredibly high resolution. And so if you like, you can take output here and make publication quality graphics. Now, another way to get output in JMP, of course, is printing. Now, printing is great because it's a good static version of your data. So this is available, as you might expect, under File Print. If you're on a Mac, you can save it as a PDF directly. So right-click, Save as PDF. On the PC, if you would like to save it as a PDF, you'll have an Export menu, which will allow you to do that. If we go to Export on the Mac, we'll see some different options here, Image, HTML. So printing is a fine option. Probably the best way is going to be making a report. Now I want to talk about reports just a little bit. So reports come in two varieties: reports with the data referenced and reports with the data embedded. Now, let me show you where these options come up. If I'm in a platform and I've created some kind of output, if I go to File, Save As, it's going to come up as graphbuilder.jrp. Let me click over to my desktop and I'm going to click Save. Now, JMP will prompt me. It'll say, this report depends on data. Of course, it's creating a report and it's using data from a data table. What do I want to do with those data? Would I like to reference the data, or would I like to embed the data? Now, let me give you an idea of what these are. Oh, I can't expand those right now. Well, before I click, let me explain. If I click Reference, what JMP will do is when I open this report again, it'll look for an open window that's called Consumer Preferences. And if that window is open, or if it can find the file on my computer, it'll simply open that data table and use the data there. So what this means is the report that I'll save using reference as an option will be very small. It will be effectively just some script. If I click Embed, what JMP will do is pull the data into the report file itself so that when I open the report again, the data is stored with the report. And so think about this. If you would like to send your report with the data itself, you probably want to use Embed. If instead you're going to be creating reports like this, maybe this is some report you have to make every week for some analysis, you may want to use Reference, because then if you change your Consumer Preferences data table, maybe you update it with new data for the last week, when you open the referenced JMP report, it will effectively rerun the analysis on your new data. And so you can save dozens of these reports with reference to your data table. And then if you update your data, you simply have to open all those reports and you'll have brand new analyses. So a very useful feature in JMP. Now I want to talk about two more quickly. So journaling and jump. Journaling and jump you can always access using Command J if you're on a Mac, or if you're on a PC, it's Control J. Let me show you what that looks like. Here I'm in just some output window. I'm going to press Command J, and what I'll get, it actually journaled it to the bottom of the journal I'm currently using here. It journaled the actual output. And so journals, like the one I'm using, can contain anything you want from your outputs. So it can be a graph builder output, it could be a distribution platform output, it doesn't actually matter. I'm going to go to the selection tool and actually just delete this from my demo journal here. But the great thing about journaling is that the output is dynamic still. You can click and select icons, but it's static in the sense that it doesn't reference any data. And so if you are creating a log of your analyses, journaling is a great way to keep track of what you've done. Pretty much as a habit, if I'm doing real analyses for research, every time I get an output, I'll just journal it to my window. That way I have a running log of every analysis I ran. And the nice thing is under the red triangles for the journal, there'll still be a script menu, and scripting in JMP is really comprehensive. And so for any output you get, you can always create a new script. Let me just show you what that looks like really quickly. And so if you ever want to rerun analyses, the script itself is stored in something that's journaled. All right, so last bit, I won't show it to you, but I just want to point out that JMP will also save output as HTML5. So if you ever would like to save dynamic output, so I'll just actually show you really quickly for this. Let me just get a distribution output here. The export option in JMP has this interactive HTML with data section. And if you create interactive HTML, I'll just save it really quickly here and open it up. It just saved to my desktop. What this will look like is in your browser, a mini version of your output, which is still dynamic, still selectable, still shows you the gray triangles to hide output, and is still contextualized. So because it's in HTML, it won't have the option to create new analyses, but certainly if you need to share data with people, this is a great way because you can make interactive HTML files that are still beautiful and easy to use. All right, so that was saving and sharing your work. Now, I'm loquacious and I talked a lot, so I want to pause and actually stop for questions to make sure we have time for those. I'll give you my information though, because of course, if I covered anything too quickly, if you like more information, I love answering questions and helping people learn JMP. And before I take any questions, I just want to point to some resources, jmp.com/teach. And so this is a great place to go if you're looking for, let me actually pull up my JMP window here. Under resources for users, so jmp.com/teach will take you essentially to this section, which has a lot of learning materials. So let me actually just show you directly what that is, jmp.com/teach. Oh, well, my internet's going to be a little bit dodgy, I think. But a lot of resources for learning JMP online. Certainly the best way to do it is always working with sample data. And let me just go back to where I was. Under the resources for users and learning library, there's this really extensive documented section where if you go to any of these little folds, I'll click on basic inference, proportion, and means. You have the option for different types of resources. And so these all answer the question of how do I do something in JMP? So if you want to know how to do a chi-square test for a two-way table, you can get a one-page guide, which are printable PDFs that take you through the analysis with sample data. And you can also click Watch Demo, which will pop over to YouTube and show you a 3 or 4 minute demonstration of the particular output. All right, so now I'll stop talking and hopefully take some questions from you guys. I'm glad you've been able to join, and I know I ran a little long, so if you have to jump off, I understand.